Changes in a system from an initial state to the final state were made by a different manner, that delta H remains same but Q changes, because delta H is a path function and Q is a state function. Delta H is a state function and Q is a path function. Both delta H and Q are state function. Both delta H and Q are path functions. Now according to the question, the initial and the final stages were made by different manner, and delta H was same and Q had changed. Why? Because as we know, delta H is a state function and it only depends on the initial and final stage, that is H2 minus H1, and Q, that is the heat, it is a path function as it is dependent on the path which follows. So the perfect option over here is delta H is a state function and Q is a path function. The cooling in refrigerator is due to reaction of the refrigerator gas, expansion of ice, the expansion of the gas in the refrigerator, the work of the compressor. The correct option here is the expansion of gas in the refrigerator, as it follows Joule-Thomson principle. The intensive property among these quantities is enthalpy, mass, volume, mass, volume. As we know, the intensive properties are the ones which are independent of the amount of matter present, the correct option over here is enthalpy, because it is independent of the amount of the matter present. If in a container neither mass or nor the heat exchange occurs, then it constitutes a closed system, open system, isolated system, imaginary system. As we know that neither mass or heat can be exchanged, so it is an isolated system. A mixture of 2 moles of carbon monoxide and 1 mole of oxygen in a closed vessel is ignited to convert the carbon monoxide to carbon dioxide. If delta H is the enthalpy change and delta E is the change in internal energy, then delta H is greater than delta E, delta H is smaller than delta E, delta H is equal to delta E. The relationship depends upon the capacity of the vessel. Now, the reaction between the carbon monoxide to give oxygen, we know it is an exothermic process. As it is an exothermic process, delta H would be negative as the heat is evolved. Therefore, delta H would be smaller than delta E, that is internal energy, and the correct option over here is B. Between delta E and delta H is, as going to the formula for internal energy, it is delta H plus P delta V. So here the correct option is option D, which is the correct reaction between enthalpy and the internal energy. According to the reaction, that is delta E plus P delta V, the P delta V can also be written as nRT. Therefore, now if for the reaction delta H is equal to delta E plus P delta V, we shift this term to this side, the reaction is delta E H minus P delta V, that is delta E. Now this option is given here as D option, which is correct. Then we have option this, that is B option, and this is the formula. So the incorrect one is C. Hess law is applicable for the determination of heat of reaction, formation, transition, all of these. Now Hess law is basically applicable to all the systems, as it only shows that enthalpy change, whether the reaction takes place in one step or multiple steps, the end of the is the same. So basically it is applicable to all of this. Basically it is applicable to all of this. An ideal gas at constant temperature and pressure expands, then its internal energy remains constant, internal energy decreases, internal energy increases, entropy first increases and decreases. Now here the temperature and pressure is constant and the gas is expanding. Therefore, the internal energy would be unaffected. For the reaction given below, the change in internal energy is, now here going for the formula, that is delta H is equal to delta E plus P delta V, or we have other form of reaction, that is delta H plus delta E is equal to delta E plus nRT. Now here nRT, the number of moles, that is the change in number of moles, is 0, as the oxygen gives carbon dioxide and water, and 2 minus 2 is 0. Therefore this whole term becomes 0. Therefore delta H is equal to the change in internal energy. Therefore the option A is most suitable for it. A system absorbs 600 joule of heat and work equivalent to 300 joule on its surrounding. The change in internal energy is 300 joules, 400 joule, 500 joule and 600 joule. Here the system is absorbing 600 joules, that is the heat absorbed is 600 joules. It is endothermic. The work done, that is W, is 300 joules. Now here only 300 joules work is done, so the leftover is 300 joules. Therefore the correct option, that is change in internal energy, is 300 joules. In an isochoric process, the increase in internal energy is equal to the heat absorbed, equal to the heat evolved, equal to the work done, equal to the sum of the heat absorbed and work done. Now as per the formula, delta H is equal to delta E plus P delta V. The system is an isochoric process, that is change in volume is 0, as the volume is constant. Therefore delta H is equal to delta E. Therefore it is equal to the amount of heat absorbed. Calculate delta H in joules for graphite to carbon from the following data. Now here graphite is converted to diamond. Therefore the enthalpy would be delta H, that is H2 minus H1, that is from graphite, that is 393.5 joules minus, which gives us the option of 1.9 kilojoule, and converted to joules we get 1900 joules. When disorder of a system increases, the change is said to be exothermic, non-spontaneous, endothermic, spontaneous. When the disorder increases, the entropy of the system increases, and therefore it would be a spontaneous reaction. Identify the correct statement regarding a spontaneous process. For a spontaneous process in an isolated system, the change in entropy is positive. Endothermic processes are never spontaneous. Exothermic processes are always spontaneous. Lowering of energy in the reaction process is the only criteria for the spontaneity. Now here, the lowering of energy in the reaction process is the only criteria for spontaneity is wrong, as increase in the energy may also be the reason for spontaneity. Exothermic processes are not always spontaneous. Endothermic processes are never spontaneous is a wrong statement, as we know that ice is an endothermic process, then it is spontaneous. Now going off to the option A. Now for a spontaneous process in an isolated system, the change in entropy is always positive. That is the correct option. An engine operating between 150 degrees Celsius and 25 degrees Celsius takes 500 joules heat from a higher temperature reservoir. If there are not frictional losses, then work done by engine is. Now applying the formula, that is W by Q is equal to T2 minus T1 upon T2. Converting the temperatures, this let's consider 150 as T2, converting it to the Kelvin. Substituting it into the formula, and taking Q on this side, we get the work done, which is equal to 147.7 joules. In the above reaction occurs, the entropy remains same, decreases, increases, none of these. As we know, the entropy, that is disorder of a particular system, is highest in gases, then in liquids, then in solids. Now here the solid is converted to the gaseous state, so the entropy here increases. A heat engine absorbs heat Q1 at temperature T1 and heat Q2 at temperature T2. Work done by the engine is violating first law of thermodynamics. It violates first law of thermodynamics if Q1 is negative, violates first law of thermodynamics if Q2 is negative, does not violate first law of thermodynamics. Now here Q1 plus Q2, it does not violate the first law of thermodynamics because it is just dealing that first law just deals with the statement that energy is conserved, and the second law states that the entropy, that is entropy of the surrounding plus the system, is always constant. So this does not violate the first law of thermodynamics. Adsorption of gases or on solid surface is generally exothermic because enthalpy is positive, entropy decreases, entropy increases, free energy increases. It is an exothermic reaction because here entropy decreases. As the entropy decreases, the disorder of the system decreases and thus the adsorption takes place. The heat content of a system is called internal energy, entropy, free energy, enthalpy. The heat content of a system is called enthalpy. Enthalpy of solution of sodium hydroxide and water is minus 41.6 kilojoule per mole. When sodium hydroxide is dissolved in water, the temperature of water increases, decreases, does not change, fluctuates indefinitely. Now when NaOH and water react, the reaction is exothermic, which releases the heat to the surrounding and therefore the temperature of the water increases. In which of the following entropy decreases? Crystallization of sucrose from solution, rusting of iron, melting of ice, vaporization of camphor. Now going on to the crystallization of sucrose, that is option A. Here sucrose, that is solid, is converted to the liquid. Therefore, the entropy increases. In the second option, there is rusting of iron. Now here the iron oxide formation is deposited over iron. Third option is melting of ice, wherein the solid is again converted to liquid and the entropy increases. The vaporization of camphor. Vaporization of camphor includes solid to gas, that is the entropy increases. Now here melting of ice and crystallization of sucrose from solution. From these two, the correct option is the crystallization of sucrose from solution, where in which of the following entropy decreases? Crystallization of sucrose from solution, rusting of iron, melting of ice, vaporization of camphor. In vaporization of camphor, that is the D option, the camphor, that is solid, is converted to the gaseous state, that is the entropy increases. Then we have C option, that is melting of ice, solid is converted to the liquid state, entropy increases. Rusting of iron, here the iron oxide is formed and therefore here also entropy increases. Now crystallization of sucrose from solution. Here liquid is converted to solid and therefore entropy decreases. So the correct option is A. For the reaction to occur spontaneously, delta H minus delta T delta S must be negative. Delta H plus T delta S must be negative. Delta H must be negative. Delta S must be negative. The correct option over here is the A option. Now here the hydration energy should be more than the lattice enthalpy, and this statement is applicable to P and R. So the correct option over here is P. Which of the following gas has the highest heat of combustion? The highest heat of combustion will be linked to the highest number of the carbon and hydrogens present, and the highest amount of carbon and hydrogen are present in ethane. The heat required to raise the temperature of body by 1 Kelvin is known as the thermal capacity of that particular system. Given the bond energies as the follows, the enthalpy of the following reaction is 93 kilojoule, that is option A. Sodium chloride is soluble in water but not in benzene because the delta H is greater than delta H lattice energy in water and delta H hydration in delta H. Going to the reaction, substituting the values given, here the correct option we get is, the correct option over here can be the hydration energy, that is H, is larger than the lattice energy in water and not in benzene. So the correct option here is B. The water molecule dissociates as the following. The average bond energy is 914 divided by 2, and the correct option is D.